At 03:27 hours local time, the first Flamingo cruise missile punched through the reinforced steel door of the Guidance Module Integration Building at the Raduga State Machine Building Design Bureau in Dubna and detonated its 1,150-kilogram warhead inside the main electronics hall. The blast pressure exceeded anything the building's structure was designed to withstand. The reinforced roof buckled upward, cracked along its central beam, and collapsed inward. Precision assembly benches, GLONASS inertial calibration rigs, terrain-matching database servers, and racks of navigation computers waiting to be installed into KH-101 cruise missile airframes were crushed, shattered, and buried under falling concrete and twisted steel. A fireball climbed through the broken roof and lit up the factory campus in orange light, throwing long shadows across the assembly halls, test facilities, and storage bunkers stretching east along the Dubna industrial corridor. But this was not just another factory fire. The Raduga Design Bureau was where every KH-101 cruise missile that had ever hit a Ukrainian city was born. Every missile that had torn through apartment buildings in Kyiv, ripped open hospitals in Odessa, collapsed school roofs in Kharkiv, and shattered power stations in Dnipro had been assembled on this campus, tested in this building, loaded onto a transport truck in this parking lot, and driven south to a bomber base where a Tu-95 MS crew mounted it onto a rotary launcher and carried it 1,500 kilometers to its target. In July 2026, Russia had launched 381 missiles at Ukraine, the highest monthly total since the invasion began. 44 of those were KH-101 cruise missiles assembled at this factory, and the rate was climbing. Ukraine had just struck the source, and the woman who made it possible was not a soldier. She had no rank, no uniform, and no security clearance. She was a 24-year-old civilian volunteer working from a rented room in Lviv, with a personal laptop and 3 monitors she had bought with donated funds. Her name was Olena Tarnavska. She was a former computer science student from Kharkiv. On March 14, 2024, a KH-101 cruise missile hit her apartment building at 04:11 hours local time. She was sleeping on the 3rd floor. The missile struck the 7th floor and detonated its 400-kilogram warhead inside the residential structure. The blast wave collapsed the upper floors downward. Olena woke to darkness, concrete dust, and the sound of steel groaning above her. She crawled out through a gap in the stairwell wall. 14 of her neighbors did not. 6 days later, she joined a civilian open-source intelligence network that fed targeting data to the GUR, Ukraine's main directorate of intelligence. Her specialty was pattern analysis. She tracked Russian military logistics by cross-referencing publicly available data, dashcam footage, traffic cameras, social media posts, satellite imagery, and shipping records. She was not the fastest analyst in the network. She was not the most experienced. But she had a quality that made her dangerous to Russia. She did not stop. When she found a thread, she pulled it until the entire fabric came apart. And in the first week of August, after Russia's record missile month, she found the thread that would lead to Raduga. It started with serial numbers. After every KH-101 strike on Ukrainian cities, bomb disposal teams, first responders, and military forensics units photographed the missile fragments scattered across the impact sites. Many of these photographs were published on Ukrainian Telegram channels, often showing twisted metal panels with stamped alphanumeric codes. Most analysts ignored the serial numbers. They were interested in the warhead type, the guidance system fragments, and the impact pattern. Olena was interested in the numbers. She began collecting them. Over 3 weeks, she cataloged 114 KH-101 serial numbers recovered from strike sites across Kyiv, Odessa, Kharkiv, Dnipro, and Zaporizhia. She entered each number into a spreadsheet, sorted them chronologically by strike date, and began looking for the pattern she knew had to be there. She found it on day 9. The serial numbers followed a sequential production batch system. Each number encoded a batch identifier, a unit sequence within the batch, and a date code. By mapping the gaps between consecutive batch numbers against the dates of the strikes, she could estimate how many missiles were being produced per month. In January, the gap suggested approximately 25 per month. By April, 32. By July, 44. Russia was not just launching more missiles. The Raduga factory had accelerated its production rate by 76% in 6 months. And the numbers suggested the rate was still climbing. Olena cross-referenced the production batch timestamps with commercial satellite imagery of the Raduga complex in Dubna. She identified every building on the campus and compared current images with historical passes dating back to 2023. One building stood out, a long rectangular structure that had appeared on the eastern edge of the campus in late 2025. Heavy vehicle access, reinforced roofing, thermal signatures consistent with precision electronics work. This was the building that did not exist before Russia began accelerating production. She believed it was the expanded Guidance Module Integration Hall, the facility where GLONASS inertial navigation units and terrain-matching computers were installed and tested before final assembly. Then she found the shipping cycle. By tracking military-registered transport vehicles photographed near the Raduga complex on Russian dashcam footage and traffic camera images shared on social media, she identified a 48-hour delivery pattern. Completed missiles were loaded onto specialized transport trucks every Tuesday and Friday night, driven south under armed escort, and distributed to bomber bases. If Ukraine struck during the shipping window, the attack could destroy finished missiles staged on the loading dock, in addition to the production equipment inside. Olena submitted her analysis through the civilian OSINT coordination channel to her GUR liaison, Captain Ihor Koval. He reviewed the data and responded within a day. Tarnovska, this is solid analytical work, but Raduga is 120 kilometers north of Moscow. It sits inside the deepest layer of the Moscow defense umbrella. S-400, S-350, Tver, Pantsir, and the densest electronic warfare blanket in the country. We have looked at Raduga before. The consensus is that it cannot be reached. Every flight path puts the formation through 3 overlapping S-400 engagement zones. Send your serial number data to forensics and move on to something actionable. Olena read the message twice. Then she opened a new folder on her laptop and named it Kovadlo, the Ukrainian word for anvil. She was not going to move on. She was going to find the route that everyone else had decided did not exist. For the next 12 days, she worked alone. She mapped every air defense system in the Moscow Northern Defense Belt, using a combination of satellite imagery, intercepted signals data shared by other OSINT analysts, and Russian military enthusiast forums, where servicemen occasionally posted photographs that revealed equipment positions. She plotted S-400 battery locations, S-350 coverage arcs, Tor M2 positions, Pantsir S-1 deployments, and electronic warfare installations. She calculated radar coverage zones, engagement ranges, and overlap areas. The Moscow air defense umbrella was optimized to protect the capital from the southwest and west, the directions Ukraine had historically attacked from. The coverage from those sectors was impenetrable. Multiple overlapping S-400 engagement zones created a wall that no drone formation could survive. But the northern sector was different. The coverage from the northwest, over the sparsely populated forests of Tver Oblast, relied primarily on a single S-400 battery at Solnechnogorsk. Its radar was partially masked by terrain and dense forest canopy that degraded detection of low-altitude targets. The forests themselves were vast, flat, and uninhabited for stretches of 50 to 80 kilometers, providing natural radar masking for anything flying at treetop altitude. Olena calculated the flight path. A formation entering Russian airspace from the northwest, cutting through the Tver forests at 30 to 50 meters altitude, could approach Dubna from a direction Russia had never been attacked from. The Solnechnogorsk battery could detect them eventually, but its radar would struggle with targets hugging the canopy. The detection range against a cruise missile flying at treetop altitude through dense forest would be significantly shorter than the system's theoretical maximum. If the formation was fast enough and low enough, it could close the distance before the battery generated enough firing solutions to stop the entire wave. She built the complete dossier, 103 pages. The serial number production rate analysis, the factory building map with each structure identified by function, the shipping cycle with Tuesday and Friday night transport windows, the guidance module integration building as the primary target, the northwestern approach route through Tver with radar coverage calculations for every segment. She encrypted the file, uploaded it to the GUR coordination server, and sent a single message bypassing Captain Koval entirely. Raduga can be reached. Route attached. Production rate is 44 per month and climbing. Every month we wait is 44 more missiles. Request direct review by targeting directorate. 2 days later, she received an encrypted response. Report to Kyiv. Bring your laptop. The mission was approved 72 hours later. The attack package was designated Kovadlo. 84 long-range attack drones, the largest and most diverse strike package Ukraine had ever assembled for a single target. The primary element consisted of 24 Flamingo cruise missiles, Ukraine's domestically produced long-range weapon with a range of 3,000 kilometers, a warhead of 1,150 kilograms, and terrain-following navigation using radar altimetry and AI-assisted terrain matching. Each Flamingo cost $600,000, roughly what Russia spent on a single day of missile production at Raduga. Supporting the Flamingos were 36 Behemoth heavy strike drones carrying 300-kilogram warheads and 24 Sikin-type saturation drones for air defense exhaustion. The attack was timed for Friday night. The shipping window, completed Kh-101 missiles would be staged on the loading dock waiting for transport trucks. The Flamingos would launch from concealed positions in western Ukraine and fly the longest route, northwest through Belarusian airspace, before cutting south through the Tver forests toward Dubna. The Behemoths and Sichins would launch from Sumy and Chernihiv oblasts on shorter routes from the west and southwest, deliberately entering the traditional attack corridors to pull the Moscow air defense umbrella in the wrong direction, while the Flamingos approached from the undefended northwest. Total flight distance for the Flamingo element, 1,700 kilometers. Estimated flight time, just over 5 hours. Every month Ukraine failed to destroy this factory. 44 more Kh-101 cruise missiles would roll off the production line and fly toward Ukrainian cities. That was the number the entire mission was built around, 44 per month. 44 families destroyed, 44 apartment buildings hit, 44 reasons this mission could not fail. At 2100 hours local time, 84 drones launched in sequence from 3 separate sites across Ukraine. The 24 Flamingos left first, climbing to cruise altitude and banking northwest toward the Belarusian border. Their terrain-following systems activated as they crossed into Belarusian airspace, dropping to 50 meters and hugging the ground. Behind them, 36 Behemoths and 24 Sichins launched from Sumy and Chernihiv, heading east and northeast toward the traditional Moscow attack corridors. At 23:42 hours, the Western Diversionary Force of 18 Behemoths and 12 Sichins crossed into Russian airspace over Bryansk Oblast, heading directly toward Moscow from the southwest. Within minutes, the Nebo-M surveillance radar network detected them. The contact was classified as a mass UAV formation and immediately transmitted to the Moscow Air Defense Command Center. The S-400 battery at Naro-Fominsk received the engagement order and began tracking. This was exactly what Ukraine wanted. Every radar dish pointed southwest was a radar dish not pointed northwest. The Naro-Fominsk battery opened fire. 4 missiles launched against the leading Sichin group, 3 kills. The Sichins climbed and amplified their signatures, pulling fire toward themselves. 4 more missiles launched. 2 more Sichins destroyed, 1 missile detonated in ground clutter, 1 missed entirely. The Behemoths behind the decoy screen dropped to 100 meters and continued northeast, absorbing the attention of every air defense operator in the southwestern sector. At 0011 hours, a second diversionary force of 12 Behemoths and 8 Sichins entered Russian airspace from the west over Smolensk Oblast. A second Nebo-M radar detected them immediately. The S-400 battery at Kubinka received an engagement order. Moscow's western defense was now fully committed, tracking 2 separate drone formations approaching from 2 traditional attack directions. Missiles launched. Sichins were destroyed. Behemoths dove into the terrain. The entire southwestern and western air defense network was engaged in a furious interception battle against 60 drones that were never going to reach the real target. At 0108 hours, the 24 Flamingo cruise missiles crossed the Belarusian-Russian border over Tver Oblast and entered the forest corridor Olena had identified. They were flying at 40 meters altitude, threading between the treetops at 550 kilometers per hour. Their terrain-following radar painted the ground ahead, adjusting altitude continuously to maintain clearance above the canopy, while staying below the radar detection threshold of the Solnechny-Gorsk battery, 70 kilometers to the east. For 23 minutes, the Flamingos flew through the Tver forests without detection. The dense canopy absorbed and scattered the radar energy from the Solnechny-Gorsk battery's surveillance sweeps. The cruise missile's radar cross-section, already small by design, blended into the ground clutter returns from millions of trees, power lines, and rural structures scattered across the forested landscape. At 0131 hours, the formation emerged from the densest section of forest into a more open area near the northern approach to Dubna. The Solnechnogorsk battery detected them. 18 faint returns, moving south at high speed, altitude 50 meters. The operator flagged the contact, but the classification took time. These were not coming from the southwest where the Moscow defenses were already fighting two drone formations. They were coming from the northwest, a direction no Ukrainian weapon had ever approached from. By the time the engagement order reached the battery, the Flamingos had already covered another 19 kilometers. 448 N6DM missiles launched. They accelerated to Mach 4 and raced northwest toward the incoming formation. The first missile locked onto a Flamingo and destroyed it. A fireball flashed above the tree line. The second missile tracked a target that dove below the canopy edge and lost it in ground clutter. It self-destructed above the forest. The third missile found its target and detonated, shattering the cruise missile in mid-air. The fourth chased a Flamingo that was already descending into a river valley, lost the return among water reflections, and detonated against the far bank of the river. 4 missiles, 2 kills. 22 Flamingos continued south toward Dubna. The battery launched a second salvo. 4 more missiles, 1 kill. 1 near miss that damaged a Flamingo's wing but did not bring it down. 2 missiles lost in the increasingly chaotic low-altitude environment as the formation pressed closer to the urban areas north of Dubna, where buildings, power lines, and industrial structures created a dense clutter environment. 8 missiles total from the S-400. 3 Flamingo kills. 21 continued toward the target. At 0144 hours, the S-350 Vityaz battery protecting the Dubna industrial zone detected the formation at a range of 22 kilometers. The S-350 is specifically designed to intercept cruise missiles and low-flying targets. Its 50 N6E radar locked onto the lead Flamingos and began generating firing solutions. 4 9M96 missiles, launched in rapid sequence, holding flatter trajectories designed to intercept targets at low altitude. The first missile destroyed a Flamingo at 11 kilometers. The second locked onto the damaged Flamingo with the wounded wing and finished it off. The third chased a target that jinked sharply and dove to 20 meters, lost it against a factory rooftop, and detonated against the building without hitting the missile. The fourth found its target and destroyed it cleanly. 4 missiles, 3 kills, 18 Flamingos remained. The S-350 fired a second salvo, but the Flamingos were now less than 15 kilometers from Raduga and closing at 550 kilometers per hour. At that speed, every second of flight covered 150 meters. Every second the S-350 spent calculating a new firing solution was 150 meters less reaction space. 2 more Flamingos were destroyed. 1 missile detonated close but did not kill the target. 1 missed entirely when the Flamingo crossed behind an industrial building at the last moment. 16 Flamingos continued toward the factory perimeter. At 0148 hours, 2 Tor M2 mobile air defense systems, positioned on the Raduga factory perimeter, detected the incoming formation. The Tor is a short-range system specifically designed to intercept cruise missiles and precision-guided weapons at close range. It can engage targets from as close as 1 kilometer and as low as 10 meters altitude. Each vehicle carries 8 missiles. Both Tor systems opened fire simultaneously. 4 missiles from the northern vehicle, 4 from the eastern vehicle. The Tor was brutally effective at close range, and 4 Flamingos were destroyed in the first salvo. Their proximity warheads detonated within meters of the cruise missiles, shredding the airframes. But the sheer volume of incoming fire from multiple directions overwhelmed the reload cycle. The Tor crews had 8 missiles each, 16 total. After the first salvo of 8, they had 8 remaining. The second salvo launched immediately. 3 more Flamingos destroyed. 1 missile lost its target against the factory's metal roofline. 11 missiles spent from both Tor systems. 7 Flamingo kills. 9 Flamingos and the 6 surviving behemoths from the diversionary force that had broken through the southwestern defenses were still incoming. The Tor systems had 5 missiles left between them. At 0151 hours, the 2 Pantsir S-1 systems on the factory perimeter opened fire. 2 57E6 missiles from the western Pantsir destroyed 1 Flamingo at 3 kilometers. The eastern Pantsir fired 2 missiles at a behemoth, approaching from the south. 1 hit, 1 missed. Both Pantsir systems immediately switched to cannon fire. 30mm rounds at 5,000 rounds per minute poured into the sky above the factory campus. 4 Sitchin drones that had survived the southwestern battle dove at the western Pantsir from different angles. 2 were shredded by cannon fire. 1 exploded 40 meters from the vehicle, peppering the hull with fragments. The 4th slammed directly into the Pantsir's radar housing. The explosion destroyed the fire control system. The western Pantsir went silent. The eastern Pantsir continued firing cannon rounds, destroying 1 more behemoth and 1 flamingo. But it was now the only close-range defense covering the entire complex. Its crew swung the turret frantically between targets, approaching from 3 directions. On the ground, factory security guards opened fire with AK-12 rifles and a vehicle-mounted cord machine gun. Tracer fire streaked across the campus. At 550 kilometers per hour, the flamingos crossed the remaining distance in seconds. At 0154 hours, the first wave of 4 flamingos dove into the guidance module integration building. This was the primary target, the facility Olena had identified as the heart of the accelerated production line. Inside were the GLONASS inertial calibration rigs, terrain-matching database servers, navigation computer testing stations, and precision alignment equipment that turned raw missile airframes into guided weapons capable of hitting a specific building from 1,500 kilometers away. The first flamingo struck the reinforced roof at a 70-degree angle. Its 1,150-kilogram warhead punched through the concrete and detonated inside the main electronics hall. The blast pressure exceeded 1,200 pounds per square inch at the point of impact. Calibration rigs were thrown across the room. Server racks collapsed. Testing stations were crushed. The second flamingo hit the eastern wall and detonated inside the secondary assembly area, where navigation computers were being preloaded with terrain-matching databases. The third flamingo struck the loading bay, where completed guidance modules were staged for transfer to the final assembly hall. A chain of smaller explosions followed as partially assembled electronics ignited. The 4th flamingo hit the building's power distribution room, severing electrical supply and destroying the backup generator system. The building collapsed inward. Fire consumed everything inside. At 0156 hours, 3 flamingos and 2 behemoths dove into the main airframe assembly hall. This was the building where KH-101 missile bodies were constructed, their fuselage panels joined, their internal fuel tanks installed, and their engine mounting brackets welded into position. The first flamingo punched through the roof and detonated above the assembly floor. The blast wave threw partially completed missile airframes off their assembly jigs. Welding stations, hydraulic presses, and precision cutting equipment were destroyed. The second flamingo hit the northern end of the building where raw materials and fuselage components were stored. Aluminum panels, steel fittings, and composite nose cone assemblies were scattered across the burning factory floor. The third flamingo struck the center of the building, collapsing the main structural beam and bringing the roof down onto the assembly line. The 2 behemoths hit the engine test facility adjacent to the assembly hall. 1 struck the test stand, warping it beyond use. The other hit the building's western wall, but did not fully penetrate. The wall cracked and partially collapsed, but the interior structure held. The engine test facility was damaged, but not destroyed. At 0158 hours, the final wave struck the completed missile storage bunker and the loading dock. 2 flamingos dove at the storage bunker. The first hit the reinforced concrete roof. The 1,150-kilogram warhead detonated on impact, cracking the concrete slab and driving a pressure wave through the interior. But the bunker held. Its construction was designed to withstand exactly this kind of attack. The second flamingo hit the bunker entrance, collapsing the access tunnel and sealing the blast door under tons of rubble. An unknown number of completed KH-101 missiles were trapped inside, inaccessible until the entrance could be cleared. 2 behemoths dove into the loading dock, where finished missiles were staged for Friday night transport. 4 specialized transport trucks were parked beside the dock, loaded with an estimated 8 to 12 completed KH-101 missiles in their shipping canisters. The first behemoth struck the dock platform directly. Its 300-kilogram warhead detonated among the canisters. A chain of secondary explosions erupted as missile warheads and fuel loads cooked off in sequence. The second behemoth hit the access road behind the trucks, cratering the pavement and throwing burning debris across the transport staging area. The 4 trucks were destroyed. The finished missiles were destroyed. Friday night's shipment to the bomber bases would not arrive. The final behemoth struck the factory's primary power substation on the western edge of the campus. The transformer housing exploded. The electrical feed to the entire Raduga complex died instantly. Fire suppression systems lost power. Emergency lighting failed. The campus went dark except for the fires burning in 4 separate buildings. By 0209 hours, the Raduga State Machine Building Design Bureau was burning across its central campus. The Guidance Module Integration Building was destroyed and collapsed. The main airframe assembly hall was gutted, its roof fallen, its assembly line buried. The loading dock was a chain of craters and burning transport vehicles. The storage bunker entrance was sealed. The power substation was destroyed. The engine test facility was damaged but standing. Secondary explosions continued to crack inside the guidance building as electronic components and chemical solvents ignited in the heat. Russian emergency response teams from Dubna and Dmitrov began arriving within 30 minutes. Fire crews deployed foam systems on the assembly hall fire and began cooling the walls of the storage bunker to prevent heat from reaching the sealed missiles inside. Military security forces established a perimeter and ordered evacuation of the remaining campus buildings. When the damage assessment was completed 5 days later, the picture was devastating. The Guidance Module Integration Building was destroyed beyond recovery. Every calibration rig, testing station, navigation computer, and terrain-matching database server inside was gone. Replacing the specialized testing equipment would require procurement from suppliers who were themselves under international sanctions. Estimated rebuild time, 8 to 14 months. The main airframe assembly hall was gutted. Assembly jigs, welding stations, hydraulic presses, and precision tooling were destroyed or buried under collapsed roofing. Rebuilding the production line would require 6 to 10 months of construction, plus equipment installation and calibration. The engine test facility was damaged but salvageable. Its test stand would need replacement, estimated at 3 to 4 months. The storage bunker's entrance was sealed, but structural engineers determined the interior was likely intact. Excavation of the collapsed access tunnel would take several weeks. The loading dock and the 8 to 12 completed Kh-101 missiles staged for transport were completely destroyed. The 4 transport trucks were burned out. The power substation was wrecked. The administrative building, the design bureau offices, and a secondary machine shop on the eastern campus survived. Russia retained the engineering knowledge, the blueprints, the design data, and most of the workforce. They could rebuild, but not quickly. Estimated production impact: Kh-101 output at Raduga dropped from 44 per month to near 0 overnight. Without the guidance testing facility, Russia could not verify that newly assembled missiles would navigate accurately. Without the assembly hall, Russia could not build new airframes. Without the loading dock, Russia could not ship completed weapons to bomber bases. Some partial assembly could be attempted at backup facilities in Yekaterinburg or Kazan, but no other plant in Russia had the specialized guidance integration and terrain-matching calibration infrastructure that Raduga possessed. For every month production stayed at 0, 44 fewer cruise missiles would reach Ukrainian cities. 44 fewer apartment buildings destroyed, 44 fewer families torn apart at 4 in the morning by a weapon they never saw coming. The strike did not end Russia's missile program permanently, but it bought Ukraine months of reduced bombardment that no air defense shield alone could have provided. The strike did not erase Russia's ability to build cruise missiles. It erased the factory that was building 44 of them every month. And for every Ukrainian city that was not hit in the months that followed, the woman who counted the serial numbers from the wreckage of her own apartment building had already done more than she would ever be told. In the rented room in Lviv, Olena Tarnovska's laptop still held the spreadsheet with 114 Kh-101 serial numbers recovered from the ruins of Ukrainian cities. Her name did not appear in any military communique. Her face was not shown on any news broadcast. The GUR liaison who had told her to move on never contacted her again. But the 103-page dossier that turned fragment photographs from Telegram channels into the most devastating strike on Russia's cruise missile production capability sat in a classified archive somewhere in Kyiv, stamped with a single word that a 24-year-old civilian volunteer had never expected to see next to her work: critical.